Hello everyone, this is our research presentation on emerging digital technology and policy, presented by Upeksha, Ambika and Fala. In this presentation, we provide you with a brief description of learning games and simulations and how they can be implemented inside the classroom and what are the challenges associated with these games and simulations and how e-safety measures can be used to minimize the risk with scholarly literature. Digital games are becoming popular tools in education because they make learning more interactive and enjoyable. Many digital games are designed to develop critical thinking and problem solving skills. These games usually have clear rules and specific goals which help keep students focused, challenged, and motivated throughout the game. It's important for teachers to choose the right type of game relevant to the learner's age, skill level, and interest. Simulations work like the virtual experiment, helping students understand real world processes. They let learners interact with models. Students have control to play, pause, or restart simulations. These tools also give access to things that are hard to see, like molecules or tiny cells. When using any digital tool, it is essential to use e-safety and privacy measures. There are some risks associated with games and simulations, like cyberbullying and harassment, exposure to inappropriate content, and sharing of personal information. These risks can be minimized by taking some safety measures, such as parents and educators should utilize the controls and monitor their children's online activity and selecting games and simulations that are appropriate for the player's age and maturity level, as well as teach players to protect their personal information online, including using strong passwords, avoiding sharing sensitive details, and utilizing privacy settings within games and platforms.
Challenges faced by game based learning and simulations, school policy barriers, issues like limited instructional time available to educators, difficulties in aligning games and simulation with the learning goal as stated by the national curriculum, lack of policies and frameworks supporting it makes its implementation more challenging. Lack of literacy, as educators mostly considered it additional activity rather than a pedagogical tool. Advertisements, pop-ups, and unwanted links can distract students, and instead of studying on a given task, they may go to a different site or play another game. Risk of distraction, students may pay more attention to playing games rather than learning. Extended screen time can lead to eye strain, reduce their physical activity, and can create sleeping problems among students. Overemphasis on competition, problem like over reliance on rewards, scores, and ranks can diminish their motive in learning. High initial cost, high quality games, software and hardware, and technology can be highly expensive for school. There are some ways by which we can overcome these challenges. First one is by selecting the clear learning objective. Before selecting a game or simulation, educators should be clear about the specific aim they want to achieve through these. Second is by choosing the right platforms, for example, Kahoot for maths and quizzes, Minecraft for teaching science and history, etc. Third is balancing game time and traditional methods, as these should be used to complement rather than replace the traditional teaching methods. Monitor student progress, using technology to identify areas where students struggle and adjust teaching strategies according to it. Encouraging collaborative learning by incorporating multiple player or team based learning to improve their social skills. Addressing accessibility issues by ensuring that all students have access to it. Providing guidance and support, initially students may find working with them challenging, so educators should offer clear instructions, take feedback from students to improve its engagement in class.
Next, we're gonna discuss the implementation for game-based learning and how that can fit into PICRAT model. To see the implementation of game-based learning, already an application named SimBio has been created that gives interactive science stimulation and let children explore ecosystems by adjusting variables such as food supply and climate. The stimulation guides students through ecological concepts, helping them apply scientific knowledge through experimentation and inquiry based learning. Teachers use built in analytics to access understanding and tailor instructions. Also, it is been classified in an interactive and amplification. If we want to see the implementation for the game-based learning, SimBio would be a great example, as this application makes an interactive science stimulation that lets children or students explore ecosystem by adjusting variables such as food supply and climate. The stimulation guides students through ecological concepts, helping them apply scientific knowledge through experimentation and inquiry based learning. Also, teachers used built in analytics to access understanding and tailor instructions. If we talk about the PICRAT model, this would come under the classification of interactive and amplification. As students interact with the structured digital environment, exploring cause effect relationships, while teachers use the technology to amplify their instructional practices by improving feedback, differentiation, and engagement. This classification reflects how SimBio enhances traditional teaching rather than replacing or transforming it. If we go deeper, we can see another example for the implementation of game-based learning. We can see an application named Prodigy. This is an application used in year 6 mathematics class. Students use Prodigy, a game-based learning platform that turns maths practice into an interactive fantasy adventure. As they solve curriculum aligned problems, students make decisions that influence the progress, character development, and rewards, which fosters motivation and ownership of learning. Also, teachers assign specific topics based on learning goals and track students' performance using built in analytics, allowing for real time feedback and differentiated instructions. According to the PICRAT model, the approach falls under creative and amplification, as students are engaging creatively by navigating a personalized game world and making strategic choices, while teachers use the technology to amplify their teaching by improving monitoring, feedback, and instructional targeting. Further down, you can see the references, the information that we have used to make the presentation. Thank you. Thank you for listening.